everyone. Today we have our another new episode, and we will discuss on edge computing and cloud computing. We have our world famous speaker, Professor Rob Enderle. Professor Rob, what you want to discuss about edge computing and cloud computing?
Well, the two are linked. So we in this industry we kind of ping pong back and forth between concepts. So you might remember back in the 60s and 70s, the concept was the mainframe, where everything was centralized, and we had dumb clients at the edge called terminals. And then the PC came about, and we moved everything to the edge. In fact, I remember at the time, at the company I was working at, which eventually became a division of IBM, much of what we had were on AS400s, IBM AS400s, but we really couldn't get anything done on that. And so we went out and bought IBM PCs. And I did pretty much everything that I'd done on that AS400, better, faster, cheaper, at least when the machine wasn't crashing on that PC. And so we really moved to edge computing because it was just more responsive. IT controlled or it was called MIS back then, but IT now controlled the mainframe. And our ongoing joke was the only way we get something through IT is that we sacrificed a few chickens and came up with a specialized chant. So we moved to PCs, but the issue with PCs is you're limited to the power of the machine. A little hard to collaborate on a project since it all existed on the individual PC. And remember back then, our networking capability was pretty sad. We were using modems to connect remotely and in-house. We were using things like Token Ring to make things work. And the division I was in, it was Roamlink, much slower. But since then, networks advanced. We've interconnected the PCs. Client server became a thing, and we came up with kind of a melding of one edge to the other in client server. Well, to a large extent, we still mostly were computing at the edge. A lot of the work was happening at the edge, and then along came the cloud. And the cloud kind of replaced the mainframe as a central repository for information, but instead of being on premise, it was provided by a third party, Amazon, Microsoft, Google, someone like that. And so you put all your stuff in their cloud, could be IBM as well, put all your stuff in their cloud. And again, you started acting against that stuff remotely. Well, then we got AI. And AI with billions of parameters, or trillions of parameters in some cases, created this massive LLM, large language model, that now people are starting to access and pound on. And it's creating some problems. So those problems include latency, data center loading, which is extreme, and really, it's really kind of blowing out the cost model, and it appears to be unsustainable. So we've come up with this concept called edge computing, which is really kind of not too different from what we had with PCs, where we now take that LLM and we push it back down to the PC or workstation, and we do the work there, syncing that work up to the cloud. So you maintain. So in a way, you're trying to get the best of both worlds. You get a centralized repository where the stuff is safe, and you get localized activity which lowers latency, lowers cost, and allows you to work if you need to work even if the network's down, and makes it worthwhile if you're using, because edge computing is not only for PCs. It includes things like smart cameras, where the smart camera does a lot of the initial calculations in the camera itself, and only sends the information rather than the data up to the cloud for determination. Now, the issue with edge computing with regard to sensors, when we call these camera sensors, is that you can miss stuff. So, for instance, and this came up a few years back when we were looking at a problem that Amazon was having. They had a bunch of people that were complaining that packages were arriving weeks, sometimes months late, and they couldn't figure out what was going on because none of the internal reports, and Amazon is very well instrumented, so they got internal reports for everything. All the internal reports were saying everything was fine. There was no indication of these large delays, and so they hired a forensic accounting firm to come in, and actually a forensic IT firm to come in, who could go in and look at what was going on and make a determination of what the problem was. Well, it turned out, though, the problem was a manager for one of the warehouses had decided that it would be more efficient for him for his people to deliver some of the packages rather than using their channel to deliver the packages. But those people weren't instrumented, and those were the packages that were really late. So it was not only not more efficient, it was much less efficient. And the reason it wasn't caught is because the information surrounding those deliveries wasn't making it back up to headquarters so they could determine the problem. And that becomes the problem to a certain extent with edge computing. If the edge is doing the calculations and only passing up the information, the data that may really determine what the problem is may remain at the edge. So, for instance, you've got security cameras. The security cameras are tuned to only send up when people have penetrated the site. And so you have people that dress up as cats or dogs or whatever, and they break in. Cameras look at them and say, they're animals. We're not going to report them. We're not going to report them. So there is no security breach. So as far as headquarters knows, there's nothing going on that remote site while people are going in and burning and pillaging the site, stealing from the site. So you do have to be careful when you do edge computing, that by stripping out all the information, all the data, and just sending the information, that you aren't stripping out things that you need to make a determination of what's actually going on. And that means at certain regular intervals, somebody needs to look at the data and see if the things that aren't being sent are important enough to capture. And this typically only happens when you've got a problem like that Amazon problem I cited. Ideally, you want to do this on an irregular basis so that if there's somebody doing something squirrely, you can catch that activity before it creates a significant amount of damage. So as far as an overview, that's kind of the difference between edge and cloud. Edge is when you do a lot of the computing at the edge, and you only send the information to the cloud, which backs it up and allows for management to make decisions based on that information. It's much more much less costly. Potentially, it has far less latency, at least for activities that are at the edge, and it can result in a much better implementation. But the downside is you might miss some critical pieces of data that you need to make a decision. And since you're now getting somewhat biased information coming into you, you might make a bad decision on that information that you otherwise wouldn't have made if you'd had the full data stream.
Thank you. What is the difference between edge computing and cloud computing, if you clarify?
Well, edge computing, as I say, it's when you're computing at the edge. It's so if you've got a full cloud computing, and they're not mutually exclusive, but if you've got a dumb camera and it's sending data up to the cloud, and the cloud's doing all the work to determine what's going on in that remote location, that's full-on cloud computing. All the calculations, the data storage, everything's in that centralized data center that's typically supplied by somebody else. So you can have on-prem clouds. You can have your own cloud, but it really it's back to that mainframe model where most all the activity occurs at that centralized facility at the data center. Where with edge computing, a lot of the activity is occurring at the edge, at the appliance, at the PC, at the device that's closest to the action. So it gets lower latency, but the downside is that some of the information may not be sent back to the centralized repository and may be lost as a result.
Okay. My next question to you: what does edge computing enhance real-time data processing compared to traditional cloud computing?
Well, it's because you're often not sending the data any place. You're sending information any places. What you're doing is you're lowering your data cost. You're lowering your traffic. And if you've got a lot of cameras, a lot of sensors, and they're all sending information, you can crash your network. And so this lowers your data traffic, results in a less expensive solution. And potentially you have lower latency. It really depends on where the decision's made, though. So if the edge computing is just sending up the information, it's not making any real determinations. In other words, it's not taking any action, and the action's all taken centrally. Then in some cases the latency benefit may be reduced. But in any case, with edge computing, you get lower latency, lower cost, and potentially much lower traffic. You're much less likely to bottleneck your network.
Thank you. My next questions: what are some advantages of utilization of edge computing in Internet of Things applications?
Well, that's really where it's playing right now. Is that Internet of Things is making those devices at the edge smart, So instead of sending up raw data, they're sending up information that they curate the data. They only send through what they need. So for instance, if you've got a lot of security cameras out, they're not sending a live stream all the time. They're only sending a picture when somebody enters an area where they're not supposed to be. So it lowers your traffic massively. It's much more beneficial in terms of primarily cost savings.
Can edge computing and cloud computing can be integrated?
Yeah, that's where they are. Edge computing is really has been connected to cloud computing. It's a way to lower the loading on the cloud and reduce latency. So they're not mutually exclusive. In fact, you still need the cloud or some type of centralized management connected back to those edge computers. So think of it as an evolution of cloud computing. Edge computing is a way to lower the cost of cloud computing and make it more efficient.
Mm-hmm. What are some potential security challenges associated with edge computing compared to cloud computing?
Right. So with edge computing, if you were to compromise the edge, in other words, you've got smart devices at the edge, and so they're making a determination. So if you're able to compromise the edge and get them to send false data, and because they're smart devices, you could flash them and get them to act irregularly, the cloud may not know there's a problem. Where if you're just cloud computing and the edge devices are stupid, now if you're mucking with the edge devices, you're going to get anomalies passed up to the cloud, and so it's much easier to determine that the edge has been compromised if you're not doing edge computing, because the cloud, the place where you're doing all the calculations, is at a data center, and the data center is going to be far more better secured than those security cameras that you've got placed at the periphery. So it's very hard to secure the edge. It's relatively easy to secure the cloud. Just because of physical location. So the security problems with edge computing is you've got to be able to secure those devices, or at least provide a way so if the devices get compromised, an alert goes out, and that alert is acted on timely, so that false information doesn't lead to false decisions. And so edge computing, by the very nature of it being at the edge, is far harder to secure than pure cloud computing.
Mm-hmm. My next questions: how does edge computing contribute to reducing network latency compared to traditional cloud computing model?
Well, as I mentioned before, edge computing doesn't send all the data to the cloud, at least not all the time. It sends information, and it tends to only send information when an event occurs. Where if you're talking about a pure cloud, then all the data is transferred up to the cloud, and so that's a massive amount of data taken across the entire Internet of Things. And so with edge computing, you dramatically reduce the network loading that you're dealing with, and potentially reduce the latency, because the decisions can be made at the edge without having to send the data up to the cloud, have the cloud make the decision, and then send that decision back to the edge. So you can, if it's done properly, you can lower latency dramatically. But even if it's not done properly, you'll lower traffic across the network and reduce bottlenecking and increase overall network performance.
Mm-hmm. My next questions, what are some key industries that benefit the most for implementing edge computing solutions, and why?
Well, anything that requires a lot of sensors, some manufacturing, warehousing, security, healthcare. Healthcare is a big one, because as you move healthcare into the home, and so you're remoting patients, that's a lot of information that you're going to be sending back to the hospital or the healthcare provider. And so with edge computing, you reduce that loading dramatically, and remember, with a bottleneck, you could have a situation where somebody's having a heart attack or a major medical event. And because of network loading, that information might not make it to the hospital for minutes, maybe not even hours. And the person could be dead by the time somebody responds. With edge computing, you'll get an alert locally. The alert simply travels up, so it's much more instantaneous. And so you get a faster response with EMTs, emergency medical technicians, and much more likely you'll save the person's life. So it's really improved, but can potentially improve the response time for medical. So any place where you have a lot of sensors, aerospace, So and as we move to autonomous cars are by their very nature an edge computing deployment. So the more AI you've got out and deploy out remote, the more sensors that you have that are remote, the more edge computing comes into play as a way to keep the cost down and get the performance up.
In what scenario would it be more cost effective to utilize edge computing? Yeah. And if you give some industrial example from Silicon Valley, maybe it will be helpful for our audience.
Well, so let's talk about a fab. That's where we manufacture processors. They're heavily automated, and they've got massive amounts of sensors. And if there's a problem on the production line, you need that problem corrected immediately, because if the line goes down, it can take weeks, if not months, to bring it back up again. And so in a fab, having edge computing is critical, because then the system can respond much more quickly to a problem, so that the problem doesn't escalate to a point where you have to bring the line down. So in Silicon Valley, one of the areas where you see a lot of edge computing is in the fabs and in the manufacturing plants for processors.
Okay, can you give us some example from different industry, like how different startup actually growing in this industry, how they solve the industrial complex problem, or how it can be helpful for our economy?
Well, so startups have to fit within some time. I mean, when you're a startup, your ability to create an edge computing ecosystem is pretty difficult, because you have to have all the components. But you can create a business around sensors, and that's really where startups live and breathe. Now, recognize you have to build against standards, because you've got your device has to plug into somebody else's back end, and so you have to comply with the standards of whatever back end you're going to comply with. And often you might have to comply with several, because you want to work with ecosystems that might be provided by a variety of vendors. So you need to know which vendors you're going to provide to. You need to get information from those vendors as to what kind of data and information they can receive, and then you design and build your products against a gap in that vendor's ecosystem. You don't want to compete with the Amazons, Googles, and Microsofts of the world. You want to solve a problem they're not solving, and not do it so well that these guys get interested in what you've done, and either steal your product or take your product from you, which is a real problem. So you've got to be very cautious on how you do this, but a lot of the work up front has to be done to determine what ecosystem you're going to fit into, what kind of product you're going to build, and thinking through the competitive dynamics throughout the life of the product to make sure that you can protect what it is you've created.
My next questions, like, how does the distributions of computing resource different from edge computing and the cloud computing architectures?
Ask that question again. I didn't quite follow.
Okay. My next question, what roles does the data privacy play in the context of edge computing?
Well, so with edge computing, a lot of the analysis is happening at the edge, and that analysis and information is often proprietary. As I mentioned, those edge computers are relatively unsecure, because they're not in a data center, and so you have to either risk accept that data might be captured and compromised, or you have to harden the edge so that it's far harder to compromise the information. When you're talking about a data center itself, your compromise could happen in terms of data being seized in transit or altered in transit, because that's the best way to do it. You could also alter it at the endpoint. I mean, we've certainly all seen the movies where somebody takes a security camera and puts a picture up in front of the security camera to make it look like there's nobody in the hallway when there actually is somebody in the hallway. That's a form of introduced bias. And so both methods have their problems, and both of those problems are most pronounced at the edge. The cameras, even dumb cameras, can be compromised. The data stream itself can be compromised. One advantage to edge computing is you can encrypt the data stream, making it much harder for somebody to intercept and compromise the data stream. With your typical camera feed, dumb camera feed, that data is raw, and makes that data far easier to intercept and compromise. And so there are very different security protocols you put in place depending on which one of those methods that you're going to use. And so we're talking about data privacy, making sure, particularly if it's a medical implementation, making sure that that data is secure and the equipment is secure becomes a primary focus of the overall effort. Otherwise, you're going to run afoul of various regulations that protect patient privacy.
Thank you. How we can develop a better environment for edge computing and cloud computing, and how we can develop better policy to develop this industry?
Well, policies, in both cases, that we're talking about a holistic approach to a particular technology. And here, I think, one, you've got to make sure that you pick the appropriate approach for whatever it is you're doing. If you've got sensors that aren't sending much information, say temperature sensors or something along those lines, then you probably don't need to go the edge computing route. You may, but you probably don't. Particularly if you're only sending information if you cross certain thresholds. Much like the red lights on the dash of an automobile, you don't need a lot of intelligence to fix that. On the other hand, if you really want to know what's going on, say it's a nuclear power plant, you need a tremendous amount of granularity, and here edge computing could play a tremendous role. But if critical data isn't being sent to the decision maker, then the wrong decisions are going to be made, or they won't be made timely, in which case you'll have a runaway reactor, which of course we saw in Russia is problematic, or 3 Mile Island in the United States is problematic. So making sure that you're using the right approach, the right hardware, basically the right solution for the problem you're trying to solve. You do not, one of the problems the industry often has is we start with the technology and we back into the problem. You should always start with a problem and back into the technology. So you're always focused on coming up with the best solution against whatever problem you're trying to solve, as opposed to trying to force fit a technology into a problem that may not be ideal for that technology. So really it comes back to methodology and knowledge. You need to have people that have knowledge of both approaches. They need to have knowledge of the industry and the particular use case you're talking about. And then they need to start with the problem and then back into the way to solve the problem, the technology they're going to use to solve the problem, and the vendors and everything else. If they go the other way, it will be suboptimal.
Thank you. What is the closing remarks for today's session?
Well, it's as I started, this is a pendulum. We started off with centralized computing. We moved to kind of edge computing. Then we moved back to client server, which was a blend. Then the cloud came back, which was centralized computing again. And now we've got the edge, which is more of a blend. My expectation is as we go forward, keeping focused on the blend, which is where you really can optimize an overall solution, would make the most sense going forward. Though my expectation is we will continue to ping pong between edge and cloud based largely on the companies involved and the resources available to them over time. This is going to be an environment that will probably remain in flux for the foreseeable future.
Thank you. Thank you for joining today's sessions. Thank you. Bye-bye and take care. I request all of our audience, please share our content with the government agency, corporation, and academy.